Talk about action potential. First, we're going to discuss the components of a neuron. So first we have the dendrites, we have the axon, the main leaf sheath, and then we have here the terminal branch. All these parts have a role in action potential. The dendrites receive the message the axon transmits. The main leaf sheath is what protects the axons from electronegativity, and then the terminal branch which sends out the signals. So when a neuron is at resting potential, that means it's in its polarized state. And when it's at its polarized state, it is at -70 millivolts. So what this means is that polarization, by actively pumping ions that leak across the membrane, in order for the nerve to fire, a stimulus must be strong enough to overcome the resting potential. And then, so the larger the membrane potential, the stronger the stimulus must be to cause the neuron to fire. So this again is the neuron here. Talk about resting potential when a neuron is at -70 millivolts. So we're just going to discuss that a little more. So when at resting potential, there are more sodium ions outside of the neuron and more potassium ions inside of the neuron. So I just wanted to touch base on that really quickly also. So now we're just going to go into the whole action potential chart here that I have set up. So basically, action potential or an impulse can be generated only in the axon of a neuron. So beginning at RMP, so we see that action potential travels to a threshold. And this is where local potential changes in the potential grade. So here it changes a grade. When moving up to depolarization, this is where the opening of a voltage-gated sodium channels start to open. And then here in repolarization, we see the closure of the sodium and the beginning of the opening for potassium. Once we hit down to hyperpolarization, the voltage-gated potassium channels remain open after the potential reaches again the resting level. And this is here at the -90 millivolts. So all of this occurs within the time frame of 0 to 3 milliseconds. So that's just a basic overview of action potential.